Okay, so today what I'm going to talk about is the introduction to the big data. So there will be not anything like a technical things that you need to worry about. So today will be more about introduction, more about the concepts about the difference between relational database system and the big database system. So in the first lecture, I talked about the history of a relational database system, why we developed the relational database system, and how it became so popular. So basically, we covered some history. So previously, records were maintained in a book-like system, and we store all this information written on the paper on kind of a cabinet like this. So it was very difficult to navigate information. And also there are some important information stored, something like a bank. So financial information is one of the most important information for everyone these days. And back then, those financial information about a certain person was stored in the home branch of the bank. So if I live in a certain area, there will be bank branch office around me, and I'll do my main financial transaction there. So all of my financial information will be stored there. The problem of this kind of system is this. When we have the information stored here without any information technology, we usually have to go there, and when we request money from another bank, from other person, or when we send the money to other person, it needs to go through multiple banks in the middle. So you cannot go directly because this bank, they have their own money, and this bank, they have their own money depository. So their information is not synced. So they have to communicate each other for a few days to make sure that this transaction is really valid, and then they perform this transaction. So that was like what they did back then. And the relational database came out, and relational database actually helped a lot to maintain and store this kind of information. And as I told you earlier, one of the main area which got a lot of advantage from the relational database is basically the financial sector, because relational database, it is highly structured because we go through very structured system like ER diagram, conceptual data modeling, and relational data modeling. So when we design the database system, it is highly structured. And another important advantage of a relational database is that it's always consistent. So the data stored in the system should be always up to date. So that's one of the main important concept, and that's the main important thing what relational database does. So we didn't talk much about this concept before, but the main reason why people use relational database is because of the consistency. It's one of the important database principle what people are talking about. So to explain more about consistency, it's something like this. So there is a central database which contains all the information. So let's just say that it's the bank of financial information. Then it will be now stored in the central database system, which is a relational database system. And there is a user A who is trying to update this information. So he changes. So it could be something like he may withdraw money from ATM, something like that. So if he withdraw money from ATM, the balance of his account should go down. And it's possible there might be another transaction performed by this person. So he tried to move money from his account to his account like this. So in this case, he tried to read data. So he has to see how much balance this person has. In the relational database system, the consistency is very important. What it means is that at the same time, all the information performed should be up to date. So when this person is performing update operation in the database system, the database system will ask the next person, basically the person who requests next, wait until the first operation is finished. So the first operation will be finished first, and then updated information will be shown to him if he tries to read the data of this person. So in this way, basically they are performing transaction one by one. So they perform first transaction, and the updated information will be recorded and finalized, and then second transaction will be performed, and then third transaction will be performed like this. So by doing that, the data stored in the database system is always consistent. So I'm going to give you more example about this later, but that's basically the main point of the relational database system. So that's why in the transaction system, they really like this relational database. And in many banking systems, they still use a relational database system. And the question is, why does a relational database not work sometimes? So when does a relational database fail? So that's one of the questions. So we can think about this simple example here. So let's think that there is a customer table in our relational database. So customer table will keep the information of a different customer. So we have a customer ID, first name, last name, email, and phone number like this for each customer. So it's a regular customer table. And what if we want to store 2 phone numbers for every customer? So currently we had only 1 phone number, and now we want to store home phone number and work phone number separately. Then it is quite simple actually. We can simply add new attribute, phone number 2. Then we are able to store 2 phone numbers for every customer. Simply make one more attribute, and here store additional phone number for every customer. So we can solve this problem like this. So it's working, it's not bad. And the question is this: in the future, and actually these days, people utilize many different phone numbers. So for example, in my case, I travel quite a lot. So in my case, I have a Hong Kong phone number, mobile phone number, and I have an office number, and I have a US phone number, and I have a Korean phone number, like this. So I can have like 4 different phone numbers. And people who like do international business, they have more phone numbers actually. So what if we try to store all the phone numbers for every customer? So whenever a person has more phone number, if we keep add more attributes for phone number like this, it doesn't look good, right? Because for every customer, if we make many phone number attributes, and if we simply add their phone number here, it may work, but it is not a good design. The problem is this: many cells here, as you see, will be empty. Some people may have a lot of phone numbers, like 10 phone numbers. However, most of people will not have that many phone numbers. Then in the relational database, when we design a table like this, basically we are allocating each cell. So each cell, even though it is empty, a certain memory storage is assigned to there. So one of the problem here is that we are wasting a lot of memory. So many of the cells here are left empty. But it's still working. We are just costing more memory. We are just making a big table, but still this design seems to work. However, let's think about this other case. What happens? So there's Donald Trump here. What if this guy, he does not have a phone number with a 2222 anymore? Let's say that he used to use this phone, but he canceled it, so he doesn't have this phone anymore. Then this place will be empty. But then again, it is not a good design because it's the first phone number. We don't want this to be left empty. So what we can do is that when he doesn't use this phone anymore, so if it's empty, we can simply move one phone number each to the front like this. So the problem is this: whenever a certain data is removed, like a phone number here in this case, we have to perform multiple operations to fill this gap. So there's too much time cost. So we can see that this is actually not a good design. So if we want to store increasing numbers, like increasing information in one table, this is actually not a good design. Then can there be any better way? to solve this problem in the relational database. You can think about this scenario. So what if we make phone as another entity, and we can assume that customer has phone by using this one-to-many relationship. So customer can have many phone. Each phone should belong to one customer. So that looks like actually it makes sense. Then instead of having one customer table, we'll have two tables. So here customer table, and we'll here have a phone number table. So for every phone number, we have a customer ID foreign key, and this number will represent who is the owner of this phone number. So we can design that too. So it seems okay. However, the problem is this. When we retrieve information from two tables, we have to use join. This is what we covered in the SQL. So we have to combine these two tables, and we have to match the CID from the customer table and CID from the phone number table. Basically, join is again, the join is kind of process that match data from two or more tables based on the same value, which is a primary key in one table and foreign key in the other table. And the problem of join is that actually join is a very slow process. So join requires table scan, which I'm going to explain a little bit more later. And this table scan is very slow, so it requires a lot of time cost if you use join. So does it really take that long? So let me show you some example here. So for the earlier example, so we have a customer and phone table, and customer table, let's say that we have this record, and phone number table, let's say that we have this record. So our goal is utilizing join to match and find which phone numbers owned by each customer. Then we may utilize this SQL query. So we select the customer ID, name, and the phone ID and phone number like this. From customer table, inner join phone, based on the primary key and the foreign key like this. And earlier, I mentioned that if you use join, the database system will use the table scan. So what it means is this. How join works is this. So from the first table, which is a customer table, it will look at the first row's information. So here, CID is 1, 2, 3. So based on this SQL query, we are trying to find the same CID from the phone number table. So it look at the first row in the phone table and see whether CID match. So there is match. And it look at the second row, it doesn't match. Look at the third row, there is a match. And look at the last one, and there is no match, like this. So for first row, first customer, the database system will scan the entire phone number table. So that's the table scan. It will scan the entire table for each customer. And then for matched information, it will retrieve as a SQL result. And for the second customer, it will do the same thing. So they will try to see whether CID is a 456 in a phone number table. So it will look at this, it's not match, here is a match, not match, not match. And then it will include this as a result in the SQL query, like this. And when everything is performed and finished, then this result will be returned back to you. So that's the basic concept of how the join works in the relational database if you use SQL. So the question is, how long does it take? I said the join process is very slow because it uses table scan, and we have to think about how long it will take. And in the you don't need to know too much about this, but briefly to speak, in computer science we call this concept as time complexity. So time complexity is a concept of calculating how many operations the computer system should take to get a certain result. So of course the time complexity is high, then that procedure takes longer time. So it is better to make a time complexity lower. So that's one of the optimization problem in the computer science. So let's say that in our example, we have n number of customer, and we say there's m number of, not order, phone in the table. So if we have n number of customer, and if we have m number of phone, to get this result, because for each customer we have to scan entire table, the time complexity will be n multiplied by m. So that's the main time complexity, and that's how much operation the computer needs to take. So actually it is so n multiplied by m. If we just look at this formula, it looks like you may not sure how many operation does it mean. But let's think about this kind of thing. The number of people utilizing online service, like if you think about Facebook, it says that there are 2 billion people who are using the Facebook. Then basically this n will be like 2 billion. And if one person has like 2 number, then m will be 4 billion. So basically, if you ask a computer to take 2 billion multiplied by 4 billion operation, it will take a really long time. It will not make, I'm not sure whether it can be done in like a real time actually. Some people say that it may not be a big issue because also the computing power is increasing exponentially. So I'm not sure whether you saw this graph. It shows how fast the computing power is increasing every year. So many people say that it's growing exponentially. So actually there is quite interesting information here. So currently we are 2021, so we are about here. So by 2000, our computer was able to process as much as information as an insect. So there's an insect brain here. And we are here in 2021, and we are trying to catch up. We already actually passed the mouse brain. So our computer now is able to process more operation than a small mouse can do. And there is one human here. So human is here. So in the science, it is known that a human can process about 10 power to 16 operations per second. In 2021, we are here. So in a few years, we will actually catch a human. So our computer will be able to process more information than human for every second. And by 2050 here, it says that our computer will be able to process more information than the entire human in the earth. So our computing power is actually increasing that fast. Then you may think that maybe the time complexity might not be a big problem because our computer is getting really super fast. But as the computing power grows exponentially, also the data we have grows exponentially. So that's one of the problems. So previously, when we used the relational database from 1970 to about like 1990, so at that time relational database was the most popular database system. We didn't use this system for other purpose. We only use this system mainly for business transaction, like a financial transaction basically. Because the personal computer was not that popular during the early time, and even though there was a personal computer, the computing power was not good enough for like a regular purpose. But around like 2000, from 1990 to 2000, we started to see like a development of like internet and e-commerce and online social network. So the number of data for the web application started to increase, and since 2000, it started to increase exponentially like this. So now, actually, we have much more web application data compared to the financial transaction data. So relational database still can be used for banking system because there is not much data to analyze. But if you look at like other information like online social network, the data grows exponentially every second. It's like you are all here. So let me just ask you a question. So for the last 6 hours, how many of you do financial transaction? How many of you did went to ATM and take out the money or made any online transaction? So not many, right? So maybe if you did, it will be probably 1 or 2. But thinking about like web application. So how many of you access the social network or send a message to your friend or check your email? So probably everyone did, right? Within the last 6 hours or even within the last 30 minutes probably. So basically the scale is different. The financial transaction data, it's growing. It's almost like a steady. It grows very steadily, slowly. But the web application data, it grows exponentially. So relational database, when it comes to this kind of system, it doesn't work well because the speed of data growth is much faster. So here, in this slide, it compares speed of SQL versus no SQL. So basically, here's the MongoDB and here's SQL, and the graph shows how many operations can be performed in each second. So in SQL, the yellow one is insert. So basically, SQL can perform about 100 insert query in a second. And the blue bar shows about 400 select queries can be performed in SQL. However, in MongoDB, as you can see, much more operations can be performed in a second. So in a web system, like there are a lot of users and the data is growing exponentially, the relational database definitely may not be appropriate for big data. In this case, we have to think about other alternative, something like MongoDB or NoSQL database system. So that's the main point. And this is another supporting example. So basically the big data market size, how they are growing over time. So this is a big data market size revenue, and from 2011 to 2027. So some here information are prediction, but as you see, the big data market will grow, keep growing over time for the next few decades. So there is a main, so basically the data in the big data system is different from the traditional data in the relational database. And the main difference can be summarized into these 3 ways. One is the volume, which is basically it's big data. So the size of data itself is much bigger than the traditional data. So processing will take much longer time as the data grows. And in that case, expansion of the system will be best costly if you use a centralized system. So many people say that when it comes to the big data system, you have to focus on distributed system. And the second one is the velocity, the rapid request. So how many people send a request to your server in a second? In the financial transaction, not everyone will do financial transaction at a certain time. So the number is much lower. But in the online system, a lot of people will send a request at the same time. So keeping consistency in that case will slow the process significantly. And in the online service, speed is much important. Like if I try to watch some Netflix movie and I have to wait for 1 minute, then I probably not watch it. The same for the YouTube. You try to click YouTube and you want to watch a movie and it says that you have to wait for 5 minutes. Then probably you will not watch it. So users are impatient. And the last one is the variety. So there are more different types of data. So traditionally in the financial transaction system, the data type is very simple. It's just number. Sometimes there is text, but usually it's short text. However, in the big data system, we use multimedia. So it's much more complex. And also it's difficult to fit this kind of data into predefined structure. So that's the main characteristics of the big data. So because of this kind of issue, many people know that big data system is important, and that's why the market for the big data grows every year. So there is a lot of demand for the big data solution, but the problem is that many people do not really know what big data is, and they really do not know how to handle big data. So usually in a company, when there is like an old senior member who doesn't know much about big data, he will already say something like this. So let's solve this problem by using big data, even though none of us have any idea about what it is. So this is one of the cartoon that I captured from the online. And also similarly, you can see a lot of companies who are utilizing big data for the last years. Over the past years, you can see that their stock price increased a lot because there is a huge demand there and they can utilize it to make a lot of money. And this is another question. We can also see the numbers from the education sector. So the question is this. So they do this kind of a survey regularly. In the university, and usually when they graduate, after they graduate, they send a survey and they ask what is your like starting salary and where they got placed and something like that. So we collect those information. And in the US, they asked which major in the business school provides the highest starting salary for undergraduate and the master. So I'm gonna share this information. So what do you think? Which major? Do you think finance, accounting, marketing, information system? Do you think which one will make the highest starting salary after graduation? So probably, if it's not me or if it's not this course, and if someone asked you, I think many people will say probably finance. But actually, that's not true. So you can actually see from this figure here. So this survey was actually conducted in 2015. So the exact number might be different. The trend got probably much stronger now. So here, they asked about the salaries for IS graduates and from other business majors. And the red bar is for the undergraduate students, and the gray bar is for the master students. So you can compare the number. So in 2015 in the US, if they studied the information system as an undergraduate, their starting salary is about 57,000 US dollar, which is highest actually compared to other major. So accounting, it was lower. Finance, it was the second highest, but it was lower than information system. Marketing, it was the lowest actually. And also for the master program, when they get master degree in information system, the starting salary was the highest. The second highest was marketing, third highest was finance, and the accounting was the lowest in this case. So you can see that information system, there is a huge demand from the market, and actually even the starting salary is much higher when you have the degree related to that. And this is additional information, so they also compare the bonus, how much they earn, and it says that the people who has a basically degree in the information system, they got much more bonus compared to other signing bonus, yeah, with other like business majors basically. So that's the kind of main information. So I didn't make this up. So I actually got this information from here. So if you go there, you can search this information by yourself too. And because this was a long time ago, like 6 years ago, I think now information systems major people, they can actually make more money compared to this. So it is this stage actually, it is very important to tell that you have knowledge in this kind of area. Like if you have a knowledge in information system, like a database and the big data system, machine learning, artificial intelligence, people will value it. So there's this cartoon that I got it from the online. So he asked, do you have any expertise in SQL? And he says no. And he says just put expert in no SQL because there's no SQL boom. It's one of the cartoon I found funny. And another thing here, recently during the job interview, he asked, so you are an expert in NoSQL. Are there any other technology you know where? He said, of course, no XML, no UML, no SAP, no IBM, something like that. So there are a lot of cartoon utilizing the theme of this kind of NoSQL boom and the big data boom. So let me talk something about, so basically today I want to talk about the introduction of the NoSQL. So I want to give you a brief idea about what NoSQL can do. So let's talk about that. So what is NoSQL? So I mentioned this in the first slide, in the first week. So NoSQL stands for not only SQL. So basically, traditionally we use the SQL, relational database, but there is more than that. And in NoSQL, you can forget the relationship. We don't care much about relationship. So there's no more relation, no more foreign key, there's no more join. So we don't use any of this in the NoSQL. So basically, it's a non-relational database management system. And there are several features which make NoSQL attractive. The first one is a flexible data model. So when we talked about relational database, we actually spent a lot of time for the data modeling, conceptual data modeling, relational data modeling, and we go through that kind of structured step because the relational database should be highly structured. So we know exactly what kind of attribute exists. We know exactly how different tables are related to each other. However, in NoSQL, we have a flexible data model, so we utilize a dynamic schema. So you don't define what attributes will exist in the NoSQL actually. If there is something, you add it. If there is something new, you just add it, like that. So main concept is this. When you look at the online service, it grows very fast. So financial system right now is much similar to what we used back then. So the credit card is still used for a long time, and the format of a credit card didn't change much. It still has a 16 number. It has a 3 security code on the back. Nothing much changed. And the way we utilize a credit card also didn't change much. But if you look at the online service, it changed very fast. So basically, when service is changing very rapidly, how to guarantee consistent data structure? So we cannot do that. So that's why we don't have a kind of highly structured data structure in this case. And also, it is possible more features are added over time. So if you think about Facebook, when it first came out, we only have this one, the post. We just post on our profile, and later they added the comment feature. So other people see your post and they can comment on your post. And later they added amazing things, the like button in 2009, and this became really popular feature right now. And also in 2010, they added the like button for the comment. So they keep expanding service almost every year. And then in 2016, they added more reactions like this. And in 2017, they also added 2 more reactions into their list like this. So the question is this. So if we use relational database, whenever this happens, we have to update our database system. We have to add a new attributes, and we have to update our table. And if the relationship structure changes, we have to update that too. But that is a too cumbersome process when we have to improve our online service rapidly and more regularly. So in the NoSQL, we have this dynamic schema. So this is based on the MongoDB. So in MongoDB, we keep the data in a document structure. So we adopt a flexible structure, and in MongoDB, we utilize a hierarchical structure to manage data. So basically, we say there is a user document which contain user information, and inside each user document, there will be post document. So there is a hierarchy. Post document is under user document, and it contains post information written by the user. And if people like React, they can do that. And also under post, when they add a new comment feature, it will be added under post document. So it has a hierarchical structure. So we will talk more about these details, how it can be implemented in the next week, but that's the basic structure. And later, when Facebook introduced like a like option for post or like option for comment, we can simply add that into post document and the comment document like this. So there is no predefined structure. Basically, whenever new feature is added, we add it in the hierarchy or we add it inside the document. So that's the main theme of a flexible data model. So no defined structure. And also for the post, we don't define any data type. So in the MySQL, when we design table, for each attribute, we defined the data type, whether it be number, text, or something like that. You don't need to do that in the big NoSQL system, because it can be text, it can be image, it can be video sometimes. So we don't know that. And yeah, as I mentioned, we can add a new field, new hierarchy anytime when we see appropriate. And another feature is the high data throughput. So basically, this is how they handle users' requests fastly. So let's say that we have like a big data, ABC. Then what NoSQL does is that they will split this big data into small part, A part, B part, C part, and they will store it separately in different server. So in this server, A part of data will be stored. In this server, B part, and in another server, the C part of the data will be stored. And then they make a multiple copy. Let's say that in this data on the C part, many people request this data. They want to see what's here. Then this server will be very important, and this data will be requested by many people. Then we make a copy. So C data, copy will be stored here and also stored here. And later, a certain person requests to read the part of C data. Then we redirect their request into this server. And while he's reading it, if another person requests reading data C, then we can redirect his request into another server, because we made multiple copy of the same data. So that in that way, basically, NoSQL or big data system can increase the throughput. So basically, they can handle multiple requests more efficiently. And second part is big data processing. So how they can process big data faster. So again, let's say that there's a user, he wants to read and process big data, which has a part A, B, C. And currently A, B, C is stored like this. Then what we can do is that each server will process its own data. So part A will be processed here, part B will be processed here, part C will be processed here separately. So in addition, instead of processing the entire data in one server, each different server will process a different part of data, and they will combine the results together, and they will send it to the user. So by utilizing this kind of distributed system, we can increase the speed. So that's one of the principles of the NoSQL. And one of the most important feature and characteristics that distinguish between relational database and the NoSQL is consistency. So I briefly talked about this earlier. So consistency is how consistent your data is. So let's think about this case. Part C of data is stored in these three servers. So earlier we stored here and we made a copy here. So part C of the same data is stored here and here and here in three different servers. And we received a request from a user to update certain part of data C. Then we process that request, and let's see that part C of data stored in this server is updated. So it's different now. And what happens is that now they will communicate each other regularly. So when the database system look at here and here, the information is different. So they sync it. So they update this part to be consistent with the data stored here. And at the same time, this database server is not synced yet. So they have old data stored here. And another user may try to read part C of data, and we redirect him into this server. Then the problem is that what he sees as data is actually not correct. It's old data, it's not up-to-date data. However, if it's a relational database system, we have to wait him until all the update is completed. But in NoSQL, we simply just give all the data to him. And it is fine. So that's the concept of eventual consistency. So eventually, all the data will be synced and all the data will be up to date. However, while we are doing that, sometimes there will be inconsistency in the data. And in the NoSQL system, in the big data system, we are saying that that is fine. So we are sacrificing consistency for the speed. So that's one of the main concepts. So let me tell you why it's fine in the big data system and why it's not fine in the relational database system. So here is an example. So basically database consistency can be defined as this. So it's any transaction, in definition it's any transaction started in the future has to see the effects of other transaction committed in the past. So basically when there are multiple transactions, we have to do one by one. So that's the main concept of database consistency. So let's think about this case. Let's say that we made two requests. First request is transfer 500 from account A to account B. And the second request we made is withdraw $300 from account A. And if the database receives these two requests, if it is a relational database, it will handle the first request first. So it will check for the request A, first request, it will check whether there is more than $500 in account A. So account A current balance is 600. So it's more than 500, so we perform transfer. Then A's new balance will be $100 because $500 is transferred to account B. So while doing that, we hold the second operation because the first operation is still performing. And when it is done, we start the second operation. Second operation is withdraw 300 from account A. So we check whether there is more than 300 in account A, and there is not enough money because we just finished the transfer. Then we reject this request. So that's what relational database does, and that's what financial system does. So in this case, consistency is very important. We have to know exactly how much money is in account before we perform the transaction. So that's very important. If we use NoSQL for the financial system, this kind of thing may happen. So NoSQL received these two requests, the same request. And earlier I said that for the speed, NoSQL sacrifice consistency. So NoSQL will try to perform these two requests at the same time. So first, it checks whether there is more than 500 in account A. It's 600, so that's true. So it performs transfer. And for the second operation, it checks at the same time whether there is more than 300 in the account A. 600, it's more than 300, so it performs withdrawal. In this case, what happens is this. After first transaction, account A's new balance should be 100. And after second transaction, account A's new balance should be 300. So there is an inconsistency. And which one is true? Actually, both are not correct. So there is a problem in this case. So that's why you should not use NoSQL for something like a financial transaction or something where consistency is very important. You shouldn't use NoSQL. So if the consistency is very important, you have to stick with relational database. So this is the main difference between these two systems. In relational database, it's always consistent, but because of that, the performance is slower. And in the NoSQL, it can handle multiple requests at the same time, so it's fast, but it has eventual consistency. It may not be consistent sometimes. Then the natural question you may ask is whether it's okay for NoSQL not to be consistent. So here is another example. So let's imagine that there is a web mobile application, something like sending a group text. So multiple people are in a group, like our group chat. And let's say that Josh is trying to send a message in this group chat. And if there are 3 people in this group chat, Josh's message will be delivered to Tom and Jenny. So let's say that Josh said this message, how about meeting on Friday? And Tom and Jenny, they receive and they will read it and they will reply. So they replied almost at the same time. So Tom replied okay. And he also replied, I'll be free in the afternoon. And then Jenny replied, Friday sounds good, like this. So let's think about what would happen if you use NoSQL. So if the transactions, this message sending transactions are happened one by one, then this message will be shown first, and they read, his message will be shown next, and Jenny's message will be shown last. However, because it's NoSQL, it's possible they might not be consistent. So his transaction is happened first, and while Tom's transaction is processing, it's possible Jenny's transaction might be processed at the same time. So her message shows first before Tom's message. And between two possible scenarios, there is no problem, right? It doesn't matter whether Tom's message is shown first or Jenny's message is shown first. It doesn't really matter. So in this case, consistency is not that important. That's why we are using NoSQL to process a huge amount of data when consistency is less important in this kind of scenario. So this is kind of main summary between relational database and NoSQL. So relational database, the data type is highly structured. In the NoSQL, it's unstructured. It's flexible. And the data management, relational database is more centralized. However, in NoSQL, they use a distributed database system. And also, from the perspective of consistency, relational database should be consistent, and NoSQL prefers eventual consistency. And for the performance, as we talked about earlier, the relational database, the performance will decrease as the size increase. So here is the graph basically. So it shows that as the volume of data increase, relational data performance decrease. For the NoSQL, it will be still same because it's scalable. It means that we can add more server, and if we have a distributed system, the multiple server can handle multiple requests at the same time. So it's scalable. Speed will not decrease. So relational database is usually appropriate when consistency is critical, and NoSQL is better for processing big data, and consistency is less critical. So this is some of the example of adoption of big data solutions. So actually this number is from a few years ago. So the number right now might be much bigger. But at the time, Apple was kind of like in the front stone, they were in the front step. So they were utilizing a lot of servers for the big data. So they were utilizing 75,000 servers, and they were processing about 10 petabytes of data, which is 10 million gigabytes of data. And Netflix is another example. They utilize about 2,500 servers, and they were processing 520 terabytes of data. And actually, for the Netflix, they have been receiving about 1 trillion requests every day. So they have to handle this huge amount of requests from user every day. eBay, they utilize about 500 servers. They have been dealing with 5 petabytes of data. So for eBay, actually they don't use a big data solution for financial transaction because they cannot do. For financial transaction, they have to use a relational database system. But they are using this big data system to manage product information and online reviews like this. And EASO is, I don't know exactly which company is this, but I heard that it's a Chinese company. So they also utilize about 270 servers to deal with 300 terabytes of data. And these days, almost all the company actually utilize a big data system at a certain extent. So if you look at some example, there are this company, Adobe, BMW, Comcast, Craigslist, Facebook, Foursquare, Google, Hulu, IBM, Instagram, LinkedIn, Nordstrom, Reddit, Saccade Capital, SAP, Shutterfly, Weather Channel, Twitter, Yahoo. Basically, all the companies you have heard about, they all utilize a big data system to a certain extent. And there are some interesting examples here. There's BMW and Saccade Capital, which I'll talk a little bit about later. So do you have an idea why BMW is utilizing big data system? Because BMW is a famous car brand, so they manufacture car and they are selling their car to customer, right? It looks like big data may not be really important for them. But can you guess why BMW is utilizing big data system? For what? Anyone who wanna guess? Like for what purpose they utilize big data system? For which type of things? Anyone who wanna say? What is it? What is it? Operation? Optimization. Oh yeah, I see. That's actually very similar. Yeah. So one of the things is this. So these days, what is it? The driverless car, right? So automatic driving is very popular. So a car like a BMW, when people buy it, usually they buy a car with an option. And in BMW, they provided this kind of navigation option. And also, so whenever a user starts their car, so their car is connected to the BMW server. So from the BMW's perspective, they are able to collect information about your driving style and where you start your drive and where you go and how fast you go, all those information. So BMW can collect those information and they can analyze your driving style, and as a marketing purpose, they can also provide you more suggestions, like more when they have a new car, they can recommend that, and when they develop new car, they can utilize your driving style and those kind of behavioral information in developing a new car and better cars. And also, utilizing those information, they can develop better automatic driverless driving car in the future. So that's why BMW is also utilizing the big data system, even though they are a simple manufacturer of a car. And the Sakeda Capital is another company. Actually, this is a company in Hong Kong. It's the what do you call it? Algorithm trading company. So instead of using human trader, they use algorithm to trade stocks and bonds and those financial products automatically. So actually, I put this here because it's my friend's company. So yeah, he was my roommate when I was in the university, and it's kind of funny because I ended up living in Hong Kong as a professor, and now he ends up living in Hong Kong as a co-founder of this company. So he made this company and he's operating in Hong Kong for the last about 6-7 years, something like that. So he also said that he utilized big data solutions. So let's go through really quick about this. So there is a few discussions here. Let's think about this. Some scenario whether SQL or no SQL is more appropriate. So let's say that Tom opened a pizza store providing free delivery in the local area. He wants to establish a database for managing customer delivery information and sales transaction. So in this example, in this scenario, should Tom use NoSQL or relational database? So how many of you think he has to use a relational database system? Oh yeah, so many, right? How many of you think he has to use NoSQL? Yeah, no one. So yeah, that's right. In this case, he has to use a relational database system because first of all, the data he's dealing with is not that big. He only provides a service in the local area, so he will not handle too much information. And also, the information he's dealing is sensitive information, like customer delivery information and sales transaction. So it should be consistent. So relational database is a better choice for him. And the next scenario is this. Tom is trying to expand his business nationwide and even worldwide. And he also wants to analyze social networks to meet customers' demands in developing new products. So which database should he use? So how many of you think that he should stick with the relational database? So how about NoSQL? Yeah, exactly. So in this case, he has to utilize NoSQL because first of all, now his data will grow exponentially. He's doing business nationwide, worldwide. And also his purpose of using data is to analyze a social network. So to analyze a social network, consistency is not that important. So because we are simply analyzing the data there is. So in this case, speed is important. So NoSQL is more appropriate. Okay, let's look at the last scenario very quick. So Jamie is the chief information officer of a startup financial firm, and she needs to decide the database solution to support financial analysts. Basically, financial analysts are those people who analyze the stock market and try to provide more insight or find a certain pattern. And also he wants to support real-time traders. So real-time traders are actually making a transaction in a real time in the stock market. So in this case, which database solution should Jamie adopt? So how many of you think relational database? Okay, some. How many of you think NoSQL? Okay. How about those who didn't raise your hand? Both, yeah, exactly. Actually, it's for both, yeah. So this is a very important point. So the decision to adopt a certain database system, it's not like black or white. So it's not like you have to stick with one database solution. In many cases, in the reality, in the company, they actually utilize both systems. So for the financial analyst in this case, NoSQL is better because they are going to analyze a huge amount of data. And for real-time traders, consistency is important. They have to see what's really happening after their financial transaction or before their financial transaction. So for them, we have to provide relational database.